Hi, my name is James Lovell, and this is my video presentation for the Mission 3 Sprint 3. This is for the CIT 110 class out of Northwestern Michigan College, which is C# Programming Introduction. I'm launching right into the program. This is take 7. All right, so we're going into Welcome the Finch Robot. Press any key to continue. Going to connect the Finch Robot. Should beep at the user. Right. We're going to go to D, alarm system. This is going to validate real quick. So if I enter a letter or a number instead of a letter, it tells me no. If I say option A, it says no, pick A or B. So that's validated. It has a list of sensors to validate. I'm going to start with the light sensors. So if I say left, it doesn't recognize that. If I say left light, oh, I left a null there. So if I say left light, it converts it to lower, which is important for a menu later on. So I get left light. I'm going to set my range type. Set my range type to same deal. If I say minimum, it doesn't work. If I say lost an M there, I say maximum, it does work. So we're sounding a maximum threshold for my light sensor. I'm going to set the threshold for the user. So current light value, it lists. We're going to set the maximum to 15. I need to set the time for my alarm, so we're going to enter 5 seconds. And set the alarm. So I tilted it towards the light, exceeded, and tripped the alarm. I'm going to show off the temperature sensor now. Temperature has to reach a minimum threshold. So I'm going to warm up the Finch robot while I continue talking. All right, we're going to set the sensors to monitor. I need to go back and set sensors. A is going to be temperature. I need to set my range type, option B, to helps if I can spell, James, minimum. I'm going to set the temperature threshold, option D. So it lists the current temperature. We're going to set it at 24. We're going to stop warming the robot now. So it should be cooling from this moment. The time to monitor, we're going to extend to 15 seconds. Set 5, and we're going to set the alarm. So as soon as it cools past 25, it should trip the alarm. It takes a temperature value every second. 24. What do you mean expired? Let's reset that alarm. Oh, it must have continued heating while I was talking. So once it reaches 23, it should trip. That's very frustrating. This is what I get for using a heating pad instead of a thing of canned air to cool it down. So I preheated the robot. Now I'm waiting for it to cool naturally to trip the sensor. I discovered blowing on the sensor actually heats it up again. All right, let's force it to trip. Let's go back to our range sensor. We're going to say 25. We're going to set a temperature larger than our current temperature, so it should trip immediately. Let's go to set alarm. 24 degrees Celsius, succeeded. Excellent. I could do that the more organic way and wait for it to trip. I can set the timer I can set the timer to monitor. I can set it all the way up to 1 minute. I entered a large number to trip the validation. But I'm not going to wait for that because I want this video to be under half an hour. I'm going to set it for 30 for my next test. I'm going to set sensors to monitor equal to all. This sets left and right temperature setting. I had an errant semicolon. I'm going to do a max. Going to set my light threshold. So I'm currently at 11, 21, and 23 degrees. So we're going to go 11, 21. We're going to set those equal to 45. And we're going to set my temperature threshold equal to 25. I set my time to monitor to 30 seconds a minute ago, and we're going to set the alarm. So this is monitoring all 3 values, and if I tilt it towards the light, let's get it above 40. 57, there it goes. That exceeded the light value. Now I'm going to reset the alarm. I'm going to stick this back in the heating pad, so we'll see the lights go to 0. But the Finch robot should continue warming up. There it goes. We exceeded the temperature value. Excellent. So that trips when either threshold is passed. Otherwise, I showed off my validation. That should be all 5 items on the skills checklist. I'm going to close the program, quit menu. I'm going to disconnect the Finch. My robot lights up but does not play sounds. And we're going to quit the program. All right, I'm going to launch into my code. So here is my alarm system main. I have a couple of extra methods that were not on the instructions, and I have several more lines of code. The instructions only got us to the point where we could set the alarm for light values, and it left us to our own devices for temperature values. So I had to improvise a bit on those. I'm just going to walk through it once over, and I do have to give credit to another student for helping me with some of the validation. So I'm going to say that right now in the presentation, and I have it written in the code where I use another person's help. So we're getting credit to not plagiarize and to be cool like that. I'm going to go through the code now. All right, so this is my main alarm system menu. This is called from the main menu of the Finch robot. Alarm system display menu. We have a Boolean for the alarm menu, string for the menu choice, string for sensors to monitor, range type, integers for the min-max threshold is for the lights, the temperature, the temp min-max threshold is for the temperature sensor, and an integer for time to monitor, all of which are required and fed to multiple things. This is my validation loop. I have a method built for validating string integers. That's part of the code I mentioned that I need to give credit to another student for. I got help with that. Actually, building all this was me, though. So I set all the code lines into here to force it to continue displaying. Then I also listed all the letter choices available, and this is the error message that you might have seen a couple times. All right, into the switch case, I have all my major methods called from this switch case. I'm just going to use this to navigate. So sensors to monitor, which we defined at the beginning of the menu, string sensors to monitor. We set it empty to make the computer happy, and we launched into static string alarm display set light sensors. This is actually for all the sensors, for left light, right light, both lights, all, and temperature sensors. Once again, I used the validate string input to sift through all of the strings. Since I had to validate several times, we built a method for it, and I called that method repeatedly to build out the rest of the program. Back to where it was. Next is the range type menu. So once again, we see that validate string input method. We set the first line is the string for the prompt. Next is the string for the error message, and then there's a string array for the list of valid inputs. So we give the user the message set range type, minimum or maximum. A good user sets one of those values, otherwise they get the error message minimum or maximum please. And again, in lowercase, those are listed there. Then that method, forgot to say, returns range type. Same with the light threshold value. I haven't shown that off yet. Back to our method calls. So for option C, for case C, I have the min-max threshold value, which is actually the light threshold value, equal to alarm system display light threshold value. I send that sensors to monitor, which we've already used, and the Finch robot, which I have named Bobbert, going to that method. So again, we send it the string sensors to monitor and the Finch robot. We have an integer defined for the light threshold value, an integer defined for the current left sensor and right sensor values, along with the temperature value. The temperature sensor outputs a double, but we converted that to integer by casting it as an integer. Makes it easier to deal with and gets rid of decimal points. So I have a switch case built off of sensors to monitor, dot to lower. If my validation didn't handle that, this would also force it to lower. I had a devil of a time with this menu because I kept misspelling things, or I had to rewrite it after I finished doing the lights to include the temperature. So I kept catching small mistakes, and I had to revalidate the program probably 15 times. So left light, for instance, it was right Lehiget. I spelled it HGT first, and I didn't catch that. And it was perfectly valid until it tried to run. So I had to catch all the exceptions there. Going through this, depending on which case you send sensors to monitor from that earlier sensors used menu, case A, you get different messages to the user. It displays the current sensor value, depending on which one you select. So left light gives you left sensor, right light gives you right sensor, both. I changed that from what was in the lecture, where we had sensors to monitor, so it would say both lights to be left and right, respectively. Temperature, I displayed the current ambient temperature. Notice I had a separate menu for setting the temperature threshold. I didn't know if there was a good way to return more than one variable from the bottom of this method. So though I could display it, and it's convenient to show, especially when you pick all of them, it's convenient to show all the information in one place instead of having to jump back and forth between a bunch of menus. I wasn't able to get away with returning two values. I had to use the single factor principle and build the method to return only one thing, and then refactor my code for the temperature. But I do have a message to the user. If you pick temperature, it shows you the current temperature value, but please use the previous menu, case D, to set the temperature threshold value. I have a validate integer loop in here, so the light threshold value equals, again, there's a prompt, a minimum, and a maximum value. So the prompt is enter threshold value for lights from 0 to 255, which is the range for an integer. let's see. I echo with a right line, user-defined light threshold is value. Then I return to the alarm system and return that value. Going back to the case menu, I go to option D. We're going to jump to that method. I do much the same thing as I did with the previous menu, only I have it set for the temperature values. So everywhere there's a light value, I directly user back to the light threshold. For temperature and all, which both use the temperature value, I list the current robot temperature and give the user at the end an option to validate their integer. Same process, string prompt, minimum, maximum. I set the minimum and maximum to 40 degrees Celsius, centigrade, because 40 degrees centigrade is, I want to say, like 120 degrees Fahrenheit off the cuff. So anything hotter than that, your room would be burning, or you would be melting the solder inside your robot. So I put that at a cap, even though that value is capable of going to 255. I don't know what the range on the Finch robot is, and I don't want to melt it to find out. So again, we echo that value and return temp threshold value to the method, or to the menu. That leaves us with actually setting the alarm and quitting the menu. So if you hit option Q, quit alarm menu is set to true instead of false. The whole menu is set to be open while not quit alarm menu. And the default is please enter a letter for the menu choice. I'm not too sure if this counts as validation or if we actually needed to do all of this. I erred on the side of getting a good grade and validating my input properly, but from my experience, whenever you have a switch case, if you type in something that's not one of the cases, the default will usually catch it. So that's a good question for after class Monday. Back to my final method, which is case F, alarm system display set alarm. I feed it the Finch robot, sensors to monitor range type, light min-max threshold value, temperature min-max threshold value, and time to monitor. All that gets me the most complicated part of the code. So again, static void, because we're not returning anything with this, just alarm system display set alarm. The robot, all the variables I mentioned. Now we have to just start declaring variables for the loop. Screen header to set the alarm, console write line, press a key to start. It waits for the user before it launches. In my case, that was pretty useful, being able to move around and set the heating pad under the robot. So we have a left, a right, and a current temperature value, all copied from earlier in the code. We go use the switch case, left light, right light, both lights, temperature, all, to list the current values, and then after waiting a second, we test for the threshold being exceeded. All of this is while within a do loop. So the do loop is contingent on threshold not being exceeded and the seconds elapsed being less than or equal to time to monitor. If threshold is exceeded, we write the alarm message exceeded. Otherwise, threshold not exceeded, time expired. That would be if the threshold is not exceeded but seconds elapsed is greater than that. Then it returns to the alarm system. I never sounded an actual tone, but if I wanted to, if threshold is exceeded, I could just write bobbert dot set tone, wait, and turn it off. The amount of times I had to test this to make it work, that would have driven me mildly crazy, so I'm glad I don't have a physical alarm tone, but that is the alarm message. All right, for all the cases we had. So for left light, if range type is equal to minimum, threshold exceeded happens when left light sensor value is less than min-max threshold value. Else, which would be for maximum, Threshold exceeded would be if left light sensor value is greater than the threshold value. That pattern repeats itself through all of my, so right light, minimum, maximum. Only I used if loops for everything else. These make more sense to me. They're easier to read for me, even though they're a little bulkier. I'm new to programming, so I'm going to go with what makes more sense, even though both work the same way. For both lights, it starts getting a little more complicated, so we have the left or the right exceeding, or exceeding or being exceeded by. For temperature, it's pretty straightforward, just a minimum. Or, again, we reverse the signs. For all, it gets interesting. So we have these really nice long if, then, else statements. So we have current temperature is less than max, or left light sensor is less than max, or right sensor is less than max. So if any of those conditions are true, threshold exceeded is true. Same thing for maximums with reversed signs. I demonstrated all of those, and I think that really about wraps up my code. I need to go down and look at my integer validation loop. Credit to this goes to JP from the online-only class for helping me set this up. I was having a rough time with validation, and he showed me a method that is reusable and moldable. It's really actually pretty clever. So you feed it a prompt, an error message, and allowed inputs. The while not valid input, you set the Boolean equal to false for valid input, so it forces you to go through the loop. You display the prompt, you clear the screen and write the prompt. User input equals readline, and then you check as it steps through valid inputs.length, so however many inputs you give it is your length. So as you step through each of those inputs X numbers of times, if there's 5 inputs, it forces you to step through it 5 times. So as it steps through, it checks for a valid input. If it's false, it kicks you to the error message which you provided earlier. But again, all of this goes to JP for helping me get that working. Other than that, all my work, and I will claim it as such. That goes to end region and wraps up my code, I believe.